The definition of the derivative, part 1. The definition of the derivative is the limit below. Note that if you plug h into this limit, you get 0 over 0, which is an indeterminate form. So we can't really solve this. We have to do some manipulation to find this limit, no matter what the function is. And our example will be use the definition of the derivative of f of x if f of x equals x minus 3x squared. Now, one of the things I do is what I call the setup, and the setup is where you copy the definition of the limit, but you leave blanks where either x plus h or x go. In other words, if you look at this definition, it's really f minus f. And remember what f is. It's a rule. It tells you what to do with the independent variable. And so what it is, it's the rule minus the rule. So here I've set up f minus f, exactly, and these are identical, these two expressions, but they have nothing plugged in yet. The idea is in this expression you're going to plug in x plus h, and in this one you're going to plug in just x, and that's step 2. And here's what that looks like. I've repeated the definition of the derivative, and then I've taken this and I've plugged in x plus h into the first one and x into the second one. This is the very important first step, because if you miss this, then you've really messed it up. So you have to be able to do that, and I always have my students write it out like this with parentheses, so you can see that it is really just f minus f. But in this f you have x plus h plugged in, and in this one you have x plugged in. Now the next step will be to simplify, and what we'll probably do is we'll distribute this negative here and we'll square this x plus h, which will give us a trinomial. And here it is simplified quite a bit. I've distributed the negative and I've squared the binomial. And now the next step would be, of course, to multiply through this by 3, and then you can eliminate these parentheses, these square parentheses, because there's just a positive sign, an implied positive sign out front, and you end up with this. Well, we still can't plug in h because we'll still get 0 over 0, but what I'm going to do next is I'm going to simplify x and minus x. Of course, they'll cancel out. Negative 3x squared and 3x squared will cancel out, and we'll end up with h minus 6xh minus 3h squared on top and h here. Now I can factor out an h and then cancel the h's, and I end up with a fairly simple expression, which does allow me to take h to 0. So that's my fourth step, is I take h to 0 and I get 1 minus 6x. Okay, so I say that the derivative of x minus 3x squared with respect to x equals 1 minus 6x.